All right, so let's look at problem number 9 here. What you have is one charge, which is located at the origin. You have a second charge, which is located some distance d over here. So this distance, I'm going to call it d, is how far the second charge is located from the first charge. And what we want to know is where could you put a third charge so that the net force on this charge is 0. So somewhere in between here, we're going to put a net charge. We're going to call it Q. And actually, I'll call it, I don't know, I'll call it Q3. And Q3 is repelled by Q2, so there's a force on Q3 to the left due to Q2, and Q3 is repelled by Q1, so there's a force to the right due to Q1, and those two forces have got to be equal if the net force on Q3 is 0. So what we have to do is set up an equation. The size of the force on 3 due to 1 must be the same as the size of the force on 3 due to 2. So you're going to find an expression for the force on 3 due to 1. So let's call this distance x. So x is how far Q3 is from Q1. And then this distance over here will be d minus x. That's how far Q2 is from Q3. And so you're going to find an expression. So this will be like k Q1 Q3 over x squared has got to equal this force, which is k Q2 Q3 over d minus x quantity squared. And of course Q3 will cancel because it's on both sides of the equations, and so will k because it's a constant. And then your goal, since you know d and you know Q1 and Q2, is to solve that equation for x. And you can solve it lots of ways. Perhaps one way would just be to graph the left side and graph the right side and look for a point of intersection. Before you go off graphing, though, think about what values of x make sense. If Q1 and Q2 are both positive, then we're looking for a value of x somewhere between 0 and d. So you can limit your search for solutions to between 0 and d. That's not true for number 10. You'll have to think a little more carefully about the next one. But that's how you go about solving that first one.